Good morning. Today we are doing our last lesson of our MCA review, which is day 6. We are looking first at solving systems of equations. So we haven't done this before, however, we have graphed y equals mx plus b. So we're going to graph two lines that are in the form y equals mx plus b and tell me where do they cross. What they mean by solve is to figure out where do these two lines cross each other, and that is the solution. System just means that there's more than one line, which we have right here, more than one line. So let's graph both of these. These are in the form y equals mx plus b. So this first one, m, or our slope, is negative 3 over 2, and b on the end here is a negative 4. The second equation, same thing. M is 1 over 2, or 1/2, and b is 4. Reminder, y goes up and down, left, or x goes left and right. If you're not sure, put the letters next to each other. You can see the letter y is longer, it goes up and down. So first, reminder that we start with b, that's where we begin. So I'm going to start with this green one on the left here. We're going to begin at negative 4 on our y-axis, right here. And then our slope tells us how to move. Remember, rise over run. Always up and down first, and left and right like our elevator. Negative 3 is going down, so from here down 1, 2, 3. And positive 2 is to the right. We can't go down and right anymore, so the opposite of down 3 and 2 to the right would be up 3 and 2 to the left. Up 3, 2 to the left. And that's it. We can draw our line through there, and then we have to graph our second line. This line, B, is for begin on our y-axis at 4, 1, 2, 3, 4. And our slope is rise over run. Rise 1, run 2. Rise 1, run 2. Or the opposite, down 1, 2 to the left. Now this one you needed to go down and left because otherwise you wouldn't have been able to see where our lines cross. But now we can see that this is where our two lines cross, and that is what our solution is going to be, as a point x, comma, y. So x first, we're to the left, negative 1, negative 2, negative 3, negative 4. And then y, we're up 1, 2, so negative 4, up 2. That would be our solution to where these two lines cross. Alright, same thing on this next one, except we need to solve the equations for y. So I'm going to start with this one. I want y by itself, so I'm going to move this negative 2x to the other side by adding 2x. So those eliminate. I have 2y equal to 2x minus 8. And then last, the opposite of multiplying by 2 is divide by 2. So we have y equals 2 divided by 2 is just 1, 1x, minus 8 divided by 2, which is 4. If you need to identify m and b, you can do so from the graph, or from the equation. Our slope, m, is just 1. As a fraction, we can put 1 over 1 here. And then b is a negative 4. Let's take a look at the next one. We need to solve this one for y as well. I'm going to start on this side by distributing. We have negative 3 over 2, and then x minus 6. So when we multiply here, negative 3 over 2 times x, just put them together. Then negative 3 over 2 times a negative 6. I'm going to multiply that out over here. It's over 1. Negative times a negative makes a positive 18. 2 times 1 is 2. And 18 divided by 2 is 9. So we have a positive 9. So we have y plus 8 equal to negative 3 over 2x plus 9. And then we want to get rid of this 8 so we can have y by itself. So I'm going to subtract 8. So we have y equals negative 3 over 2x plus 1. Now we can identify m and b. M is negative 3 over 2, and b is just 1. So let's graph both of these lines. The first one on the left here begins at negative 4 on your y-axis. So down 1, 2, 3, 4. And our slope is 1 over 1, rise 1, run 1. Up 1, 1 to the right, up and right, up and right. Or the opposite would be down and left, down and left. The other equation, b is for begin as well, beginning at a positive 1 on my y-axis, up 1. And my slope this time is negative, down 3, and positive 2 is to the right, rise over run. So we went up and down first, down 3 from that middle, or from the point we plotted, down 1, 2, 3, and 2 to the right. Oh, there you can see right there, that's where we're going to cross. But I'm going to keep going so I can create my line. Instead of down and right, I can also go up 3 and 2 to the left, just to get my line to go all the way across the page. So my solution, these two cross right here. On my x-axis, that's 1, 2. And on my y-axis, that's negative 1, negative 2. So there's my solution. Next, we are going to take a look at parallel and perpendicular lines. This is one thing that I would have you add to the bottom of your formula sheet. We already have our perfect squares. We know we start with point slope form, solve for y, and then get standard form by itself. But we haven't quite talked about parallel and perpendicular lines, so I would have you take out your formula sheet and write parallel lines. Remember, this symbol means parallel, this symbol means perpendicular. And add that parallel lines have the same slope or the same m. And then perpendicular lines, the slopes are opposite reciprocals. So opposite meaning one positive, one negative, and reciprocal meaning your fraction is flipped. So again, same information right here. Parallel lines on this side first have the same slope. Perpendicular lines have slopes that are opposite reciprocals, like one negative and one positive, and then flipped. Reciprocal, 2 over 3, 3 over 2. So first, we're going to start with perpendicular lines. Write an equation of the line that passes through the point and is perpendicular to the given line. In order to find a slope that is perpendicular, we need to find the slope of this equation that they're given to us first. We can't do that until it's solved for y. So I'm going to solve this for y. I'm going to move the x's over to the other side. So I have 2y equal to 4x plus 6. And then the opposite of multiplying is divide, so I'm going to divide everything by 2. And we get y equals 4 divided by 2 is 2x. 6 divided by 2 is 3. So here's the original equation they gave us. It's just solved for y now. Now we want an equation that's perpendicular to the given line. So this is the one they gave us. Now we want one that's perpendicular line. So a perpendicular slope. Instead of a positive 2, remember our slopes are opposite reciprocals. So instead of positive we want negative. Instead of 2 over 1 we're going to want 1 over 2. So our slope is going to be a negative 1/2. And it has to go through the point that they give us, our x and our y. So we don't need this equation anymore. We just need the point and the slope. Now if we have a point and a slope, it would make sense to start with point-slope form. Now you can copy this right off of your formula sheet. I use this one because we have a point and a slope, so that one makes sense. And I'm going to plug in what we know. Y minus y1 right here is 5, equal to our slope, which is negative 1/2, and then x minus x1, which is a negative 10. Those two negatives make positive. Then we're going to draw our line down here so we can solve it. I'm going to distribute on this side. Negative 1/2, x plus 10. Negative 1/2 times x, just put them together. Negative times a positive, I know it's going to be a negative. We want 1/2 times 10, or think of what's half of 10. Well, half of 10 is 5. So I have y minus 5. I'm going to move this down just a little bit. Y minus 5 equal to a negative 1/2 x minus 5. And our goal is to write an equation and solve for y, so I'm just going to add 5. So we have y equals negative 1/2 x, and a negative 5 and a positive 5 make 0. So there is our solution. This line would be perpendicular to the line that they gave us, this line. If they asked you to graph them, you could. There are 2 graphs down here. I'm not quite sure if I had you put those on your notes or not. If I did, let's graph it anyways. This first one, we would begin at a positive 3. 1, 2, 3. And our slope was rise 2, run 1, up 2, 1 to the right, or down 2, 1 to the left. So there's our first line. Second line, we'd begin at 0, and our slope was negative 1 over 2, or down 1, 2 to the right, or up 1, 2 to the left. As you can see, these cross at right angles. They don't cross at a nice point, I don't care about that, but they cross at a nice right angle. Like you could put a piece of paper in here and the corner would fit perfectly. Let's try the next one. This one, it says, same thing, write an equation of the line that passes through this point, x1, y1, and is perpendicular to this line. Well, this is in the form y minus y1 equals our slope, x minus x1. So we don't really need to solve for y because I know my slope in this equation is negative 4/3. Well, we want one that's perpendicular to that. So our perpendicular slope, instead of negative, will be positive. Instead of 4 over 3, it will be 3 over 4. So we're going to use that slope and this point to write a new equation that's perpendicular to it. So I'm going to plug in what I know, y minus y1, which is 1, equal to our slope, which is negative 4/3, and then x minus x1, which is 8. I'm going to solve this for y. So again, distributing negative 4/3 and x minus 8. So I'm going to multiply those out, just put them together first. I know a negative times a negative is going to give me a positive, and I want to multiply negative 4/3 times a negative 8. Again, that makes a positive. 8 times 4 is 32. 3 times 1 is 3. Oh, you guys, I made a mistake. I'm going to go back for a second. Some of you may have noticed it, but up here I used the wrong slope. I used, accidentally, this one when we wanted to use our new perpendicular slope. I don't care about this one anymore. I need to use this one, 3/4. So that will be a negative now, I know. 3/4 times x is 3/4 x. But I still need to multiply 3/4 times negative 8. 8 times 3 is 24. 4 times 1 is 4. 4 goes into 24 6 times, so that's a negative 6. So we have y minus 1 equal to 3/4 x minus 6. Write small if you don't have enough room as I do here. And then get rid of this negative 1 by adding 1. So we end up with y equals 3 over 4x minus, different signs we're subtracting, 6 minus 1 is 5. If you did graph these, you could graph this line down there, and then this one, you would actually have to solve for y if we were going to graph it. Alright, next, same thing but parallel lines. We want to know an equation that goes through this point, and is parallel to this equation. So this again is in the form y minus y1 equals our slope x minus x1. So I know my slope is negative 4. So if we want a line that's parallel, parallel lines have the same slope, so this slope also has to be negative 4. So I'm going to use this point and this slope to write a new equation. So I'm going to plug in what I know, y minus y1, which is 6, equal to our slope up here, which is negative 4, and then x minus x1, which is a negative 1, making a positive. So I'm going to distribute here, negative 4, x plus 1, negative 4 times x is just negative 4x, negative 4 times 1 is just negative 4. So we have y minus 6 equal to negative 4x minus 4. And we last need y by itself, so I'm going to add 6 to both sides. We get y by itself. We have y equals negative 4x. There are more positives. Different signs we subtract. 6 minus 4 is 2. Again, I don't know why the graphs got pushed to the bottom here. But if we wanted to graph this, we could. We could start at plus 2. And then our slope is negative 4 over 1, down 4, 1 to the right, down 4, 1 to the right, or up 4, 1 to the left. Oh, that was only 3. 1, 2, 3, 4, over 1. And draw a line through it. The other line we could graph as well. However, this one we would have to solve for y. If we did that, and right now, if you don't want to do this right now, that's okay. However, if they asked you to graph both, you would have to graph both. And we would need to distribute to get rid of our parentheses. Negative 4 times x is negative 4x. Negative 4 times negative 2 makes a positive 8. And we need to get y by itself, so I'd subtract 10. And we would have y equals negative 4x minus 2. Negative 4x minus 2. I'm just going to write that down here. So we're going to begin at negative 2. And we'd have the same slope, down 4 over 1. Or up 4, 1 to the left. My lines aren't very straight right now, but they should end up to be parallel lines. Never going to cross, never going to touch. Alright, last one. We need y by itself to find our slope because it's not in a form that we know. So I'm going to move my x's over to the other side. I'm going to add 1/4 x. So we have y equals, can't combine those, so write them separate, 1/4 x minus 1. So there's our first equation. We need a slope that's parallel. Well, parallel lines have the same slope, so this one also has a slope of negative 1/4. And here's my point that I'm going to use. Again, I have a point and a slope. I'm always starting with point-slope form because I'm always given a point and a slope. Makes sense to use that form. So we have y minus y1, which is 4, equal to our slope, which is 1/4. And then x minus x1, which is a negative 8. Those make a positive. And then we're going to distribute to get rid of our parentheses. So 1/4 times x is just 1/4 x. 1/4 times 8, 8 is just 8 over 1. So we have 8 over 4, which is really just 2. We have y minus 4 equals 1/4 x plus 2. And then last, we need y by itself. So I'm going to add 4 on both sides. So we have y equals 1 over 4x plus 6. I'm going to copy this equation down below here so I can see them both on my graph. Y equals 1/4 x minus 1. So if we had to graph these, this red one would begin at plus 6. 1, 2, 3, 4, 5, 6. And our slope would be rise 1, run 4. Or down 1, 4 to the left. So that would be our first equation. Our second one here would just begin at negative 1, and we'd have the same slope. Rise 1, run 4. Or down 1, 4 to the left. Oops, not the straightest. There we go. I'm going to fix that a little bit. Perfect. And as you can see, these lines are parallel, just as we were asked to create. Alright. Oops, I forgot to add a picture of your homework here, but you should get a picture of, not a picture, you should get an actual homework from me. And if you have questions, please let me know.